Sass class with Amanda. Hey.
Hello! In other videos we talked about the normal distribution, and in this video we'll concentrate with one specific example and show you how to solve something that you'll be encountering a lot, which is to determine the area between two values x and y. You'll see that a lot. It's a canonical normal distribution problem. Alright, so here we have the length of human pregnancies from conception to birth varies according to a normal distribution. That was nice of them to tell us already that it's a normal distribution. Apparently this normal distribution happens to also be approximately normal. Great. And we have a mu that's equal to 266 days and a standard deviation sigma, which is 16 days. And what we want to determine is what percentage of pregnancies are between 217 and 255. So the first step to any of these problems I always suggest is for you to draw what's going on. So we know we have a normal distribution, which happens to also be approximately normal, with a mu 266, okay, and a standard deviation that is 16. I think in another video we said this was 250 and that this was 282. And now what is the scenario? Well, the scenario is to figure out the percentage, or also the area between 217, which is somewhere over here, and 255, which is somewhere over here. So we want to figure out what this area is between these two values. Okay, and so let's just say that this is 217 and that this is 255. Alright, so the way to approach this is to find the cumulative proportions at 255 and 217 and subtract one from the other, okay? So we can think of this as, here is my normal distribution, this is 266, this is 255, here's the CP, or cumulative proportion, okay, minus the normal distribution. It's the same one, even though, you know, my drawings aren't perfect. And then here's 217, approximately. So when we subtract this area from that area, we get this blue area. Alright, so step one helps us understand what's going on. Alright, so what is our next step? Well, our next step is then to find our z-score. Okay, so step 2, z-scores. Alright, so in this particular example we do need two z-scores. Okay, we need a z-score for 255 and a z-score for 217. Okay, it's the only way we could find these cumulative proportions. Okay, so z1, I'm going to let that be the one with 217. So 217 minus 266 divided by 16 is equal to negative 3.06. Okay, and we can expect this z-score to be negative because these values are to the left of the mu. If you're confused as to why, you should go see one of the earlier videos where we talk about that a bit. Alright, so now for 255 minus 266 divided by 16 is equal to negative 0.6875. I am not doing this in my head. You guys are more than welcome to grab a calculator and check my work. I could be wrong. Alright, so that's step 2. We have our two z-scores, and what we want to do is once we have our z-scores, step 3, is we want to use table A. Okay, we talked about how to read table A the other day based off of z-scores, so please make sure that you refresh your memory and double check that you know how to use table A. Otherwise, I'm going to continue assuming that you know how to do so. So the cumulative proportion for Z1 is equal to 0.0011. And the cumulative proportion for Z2 is 0.2483. Okay, so we said we wanted to take one cumulative proportion and subtract it from the other. Well, we want to take the proportion associated with 255 and subtract the cumulative proportion associated with 217 from that, right? That's what our diagram is saying, in order to find the area of the overlapped, or the, I guess, non-overlapping area. Alright, so if we subtract one from the other, so 0.2483 minus 0.0011, this is equal to 0.2472. We're almost done. We were asked for the percentage, so our final answer is 24.72%. And you should get in the habit of giving full sentences for your solution. 24.72% of pregnancies are between 217 days and 255 days.
My name is Llama, and I'm here to teach you stats, skilling you up with them cold hard facts. We live in a world of technology. They're collecting information on your humanity. Social networks, gaming, and in-home software.
Hello, Alexa.
Statistics helps us be more aware. Haters gonna hate my spicy lyrics. Why you gotta be so mean? Pulling me towards your extreme moods, but the median never fails to center me. 50 to my left, 50 to my right. Got these correlation and regression tools, forget them fools. My name is Llama, and I'm here to teach you stats, skilling you up with them cold hard facts. My name is Llama, and I'm here to teach you stats, skilling you up with them cold hard facts. The mean of the means is the mean. The mean of the means is the mean. The mean of the means is the mean is the mean of the means is the mean is the mean. Be careful not to fall in love. Statistical seduction from above. Your shape so beautifully symmetric to the eye with a single peak so high. I hypothesize and can testify that your p-value is the smallest I've seen. Mix that with a large power and I reach ecstasy. Your residuals defy the rest. A small scale randomized pattern tells me you are the best fit. My name is Llama, and I'm here to teach you stats, skilling you up with the cold hard facts. My confidence is so high, 95%. My margin of error so nil, 1/10. Can you feel me? Can you feel me? I estimate your population parameter based on only one sampling. Oh, haven't the frequentists told you about me? We live in a world of data, attempting to understand life by statistical strife. The implicit bias of cops, success rate of them jocks, medical advances, and AI romances. Statistics.